Okay, here's a video on lesson 98, normal curves. I'll go through the notes real quick and then I'll give you an example of what the homework should look like and what the classwork looked like. Okay. So what is a distribution? A distribution is an arrangement of data where the height indicates a more common value. The options that you have that we actually care about, because there are actually a lot, the ones that we care about are skewed left, where it's higher because there are more low values. Skewed right, where it's higher because there are more large or high values. Normal, which is the one that we'll be talking about a lot, where the most values are in the middle of the curve, and then we have less as we go to the left, we have less as we go to the right. And then uniform, where all values have the same probability. So for instance, think of this like a bar graph, and we could say that this is heads and this is tails, and we'd be talking about coin flips. So they'd be the same likeliness of showing up, same likelihood, so they would end up with the same number of heads and same number of tails as we flipped coins over time. These are all shapes that essentially map out the top of a dot plot. So just to give you an example, this is a skew right dot plot from lesson 95. Basketball players' ages, there are more basketball players who are 12 and 11, and then we have less as we move to the left, so the curve goes down. So this is the shape over the top of it, which looks a lot like this graph right here. Okay, so that's what I mean by the distribution. It's essentially the top of a dot plot. Now, the things that are interesting and unique about the normal curve is that the normal curve is symmetrical. The mean equals the median, which equals the mode. So the mean is the average, is equal to the most common value, which is equal to the value that shows up the most often. So there are not three separate measurements, it's all the same. Now, many natural measurements follow a normal distribution curve. If you measured a whole bunch of data, shoe sizes, height, speed of a falcon in diving, right? Any natural phenomena tends to be normal. Now, here's the empirical rule, and that's really what we're focusing on today, that 68% of the data is within one standard deviation. This right here is this not a zero. This is the sigma symbol. So it's like an O with a little hat on top, kind of. So that's standard deviation. 95% of all the data falls within 2 standard deviations, and 99.7% falls within 3 standard deviations. Now, the empirical rule, what it lets you do is it allows you to use the mean and the standard deviation to state what percentage of values fall in a certain range. So to show you what that looks like, I take the same normal curve 3 times, so bell curve, and bell curve. What I do is I draw on that bell curve. Let me show you where this all came from. Okay, so I draw my curve, I draw my number line along the bottom. Now the mean goes in the middle, and then I have 1, 2, 3 standard deviations on the right, and 1, 2, 3 standard deviations on the left. Now 68% of the data is within 1 standard deviation of the mean, so it's 1 to the left and 1 to the right. So in this region here, we'll find 68% of all the values or measurements or test scores or whatever we're talking about. If we go out one more, so you'll see 1, 2, 1, 2. That'll get you 95% of the data. And over here on the right, you'll see that if I go 1, 2, 3, 1, 2, 3, you'll find 99.7%. Okay. Now, what we did was we used those numbers and the fact that the curve is symmetrical in order to find out the numbers that fall in each one of these regions. So we did the same thing. We've got the center. We went 1, 2, 3, 1, 2, 3, and then I just extended the lines up so I could get these individual regions. So here's what we did. We said that 68% must be in here. So if I divide that by 2, we find that this has got to be 34, and this has got to be 34. Now, the y doesn't matter as much because you'll have your calculator to do this for you as soon as you learn something that we call z-scores. So here are the other numbers. In here is 13.5%, and in here is 13.5%. Out here is 2.35 and 2.35. So what we're going to do is we're going to use these, and we're going to draw some graphs for the examples on the front in order to figure out what percentage of the data falls within certain test ranges. So here's how we're going to use that. For question number 5, they say, given that mu, which is the m symbol, which is the mean, and sigma, mu is 89, sigma is 3, what percentage of the data falls within 86 to 98, the range of 86 to 98. So first things first, let's draw our normal curve. I'm going to make my pen smaller so I don't have to keep switching back and forth between pages, but you might want to do this on loose leaf. So I've got my normal curve, and I've got my number line along the bottom. Now I've got this line right down the middle, and that's going to be the mean, which is 89. Okay? Make that a little more interesting looking. Now I've got 1, 2, 3 on the right, and 1, 2, 3 on the left. Now here's what I do. I take sigma, the standard deviation, and I'm going to plus 3, plus 3, plus 3 to go to the right. I'm going to do minus 3, minus 3, minus 3 to go to the left. I'm making a number line, and all I'm doing is counting up and down by sigma. So plus 3 gets me 92. Plus 3 gets me 95. Gets me 98. I want to get rid of these in here because I'm going to want to write other stuff in here. And now as I go to the left, I'm going to do minus 3, which is 86, minus 3, which is 83, minus 3, which is 80. And now I'm going to take these out as well. Now what they're talking about in this question is the range they're looking at is 86 to 98. So we need to look at that region in here from 86 to 98. Well, now there are different regions within here that have different percentages. I'll shade in this region just in case you want to see all of it. So this is the region that they're talking about from 86 all the way over to 98. Now the numbers that fall in these regions, here's the mean. So around the mean is 34 and 34. Remember that I have 13.5 and 13.5 and 2.35 and 2.35. But the ones that fall in the range that we're interested in, from 86 to 98, is 34 plus 34 plus 13.5 plus 2.35. And you could do that with a calculator. I'd rather do it piece by piece. This is 68 for those two. This is 15.85. And then when I add those up, I get 83.85%. So it's 83.85% of the data. Let's do one more. Given that mu is 71 and sigma equals 5, alright, so let's draw our graph first and foremost. So my bell curve, make it nice and wide so I can get a good drawing. Mu is in the middle, so that is going to be mu 71. I have 1, 2, 3 on the right. I have 1, 2, 3 on the left. And now don't forget, I'm counting up by sigma. So there's going to be plus 5 is 76, plus 5 is 81, plus 5 is 86. And now same number, 5, right? But I'm going to do minus 5. Minus 5, minus 5, minus 5. So 71 minus 5 is 66. Minus 5 is 61. Minus 5 is 56. Now we know what numbers are going to fall in here. I'll make this a little bit lighter. We know what numbers are going to fall in here. So let me split this up. You don't have to write all the numbers on for every single example. I'm just doing it because I'm teaching. This is 13.5 and 13.5, and this is 2.35 and 2.35. It's all a little lighter than I wanted it to be, so I'm going to highlight all of that. And just make all of that black. Okay. Now the range that they're talking about is the range of tests between 71 and 81. So between 71 and 81. So 71 is right here, and 81 is right here. So if I'm identifying just a shaded region between these two, we're talking about 34 and 13.5. So I add those two up. 34 plus 13.5 is 47.5%. Okay, and that is the idea. So good luck with that. See you in class tomorrow.